Hey guys, welcome to this quick tutorial. Today we will be designing an exhaust vent for a Lamborghini using Grasshopper 3D. Let's get started. So please go ahead and download the files from our webpage. You will find the Rhino file as well as the Grasshopper file in the resource folder. The original model I have downloaded from GrabCAD, and I will also include the link to the original file and the author in the description. All right, so once you have downloaded the files, let's open the first Rhino file. You will see a couple of layers. Let me hide the main assembly. And now you can see there are a couple of surfaces here. So this surface that you see, the flat surface, that is where we will make the exhaust vent's hexagonal texture. And this other surface which you see in front, this is what we will be using to trim out and perform Boolean difference with the entire extrusion. So the first step will be projecting the outline of the exhaust vent to this surface. So let's see how we can do that. Let's go to the front viewport and run the project command. Okay, so let's run the project command, select the two curves, press enter. Now the surfaces, they are overlapping, the flat one and the curved one from this perspective. So it's easier if we just select both of them all together. Now let's press enter. And if you go back to the perspective mode, you can see that the two curves have been projected. Now I will use these curves to trim out this surface into three parts. So let's run the split or trim command, select the surface, press enter, and the cutting objects are the two curves. And let's press enter again. Now this has splitted the surface into the outer chunk that we don't need. We have the internal chunk which we will use later on for Boolean difference. And then the outer chunk that you see here will be used as the sleeve of the exhaust vent. Okay, so I have made all of these surfaces for the next step in Grasshopper. So what you can do is just enable the third layer, okay, so that the tick mark is here. And then you can hide the other layers to avoid duplicate surfaces. Now, these are the three surfaces we will be needing in the next step in Grasshopper. So let's see how we can do that. So perfect. Now let's see how we can apply the texture in Grasshopper. But before doing that, let's make sure we have installed a plugin that we will use to create the panels. In order to install the plugins, let's go to the command bar, look for Package Manager, press enter. It's going to pop up this window. And let's look for a plugin called LunchBox. Okay, some of you might have already installed it. In that case, you will see a tick mark. But if you don't see that, you can select and press install. Okay, so once it's done, it will ask you to restart Rhino, but you don't need to restart as long as you haven't launched Grasshopper yet. But let's say if you have launched it, so please go ahead and restart and continue from this point onwards. So let's say you have installed the plugin and restarted. Now, how to launch Grasshopper? You can launch Grasshopper by either clicking on this button or going to the command bar and writing Grasshopper. Press enter. It's going to pop up this window. It might take a couple of seconds depending upon how many plugins you have installed. But once it's done, you can now move it around in your interface. And the best option is just docking it to the right-hand side so that you can work on the right-hand side using the visual nodes and see the effect of those operations on the left-hand side in your Rhino viewport. So now let's see how we can apply the texture. So the first step will be importing that base surface inside Grasshopper. So let's go to the very first tab, Params, Geometry tab. And here you will see a couple of components. So these are your parameter components for geometry, where you can import these geometries inside a specific container. In this case, the correct container will be a surface container. So let's create that. Okay. Now, in order to import that surface, you have to right-click on the container. In the options, you will see an option called Set One Surface. As you can see now, in Rhino, it is asking us to reference the surface. So let's click there. And now you can see that surface has been successfully imported inside Grasshopper. The next step is to create the hexagonal panels. So as you scroll through the different tabs, you will find a tab called LunchBox. You will find a sub-tab called Panels, and we will be creating hexagonal panels. So let's click on it and create that component. Now you might notice that the components look slightly different in your case, and that could be because your display settings are different than mine. And this is an optional setting. You can decide whether you want to draw the icons or not, or whether you want to draw the full names or not. Okay, so I'm going to leave it as it is. Now let's connect the surface as our surface input for the hexagonal cells. So you have to click and drag a cable and then connect it to there. Now, if you mistakenly connect it somewhere else, there's also a possibility to remove it. Let's right click, disconnect, and we can disconnect it. If you want to disconnect it using keyboard shortcut, you can press and hold Control. You might see this arrow turn red in color. So now we can disconnect. Okay, by making the connection, we disconnect while holding Control. Now let's define the number of hexagonal cells in the U, so in the X or Y parameter. For that, let me go to the front viewport so that I can see it from the front side. And in order to define a number value, there is also a quick way we can define these numbers. That is by double clicking on the interface. And if you write text, we can find components. We can quick search it rather than navigating through the interface. And if we double click and write a number, let's say 20 in this case, we can create a number slider. Okay, and we can connect this number slider as our input for, let's say, the U parameter or the V parameter. So let me set it to 30 and 20, and we are good to go. Now in Grasshopper, it is very important to hide the components as you progress through the script. As you are building geometries on top of another geometries, and it can get confusing. So whenever you want to hide a node, let's select the node, and then you can see the effect of that selection will also show you in green highlight in Rhino. Then you press the middle mouse button and you can disable the preview. You can select and enable the preview or disable the preview. Okay, so now we have these hexagonal cells, these polylines. The next step will be offsetting these curves inside. So let's look for the offset command. We can either go to the curve tab, utilities sub tab, and then here we can see curve offset. Or we can also double click and look for offset curve, which is this one, and use it from there. So these are the curves that we need to offset. Let's connect that. And by default, you can see it's offsetting in the positive direction by 1 unit. However, we want the offset to go on the negative side. Okay, so let's say if I want to send it to negative 0.5, so let's create a number slider of 0.50. But as you can see, this is just positive direction. So let me disconnect it using Control. And let me add a negative container. So this container will convert any number passing through it into negative number. Okay, so this is negative 63. So let's connect it. And in this case, we are going to offset it by -1. Now we don't need to see the original cells, so let's select it and hide it. Now, once we have offsetted the curve, it's better we round the corners. For that, we can again go to Curve, Utilities, Fillet. Okay, so these are the curves that we need to fillet. Okay, now you will notice that this cable that is coming out of the offset curve means that each curve is now in a new branch. Okay, let me connect a panel and show you the output in the list. And it's a bit advanced stuff, but basically each object is now packaged in a separate branch, and it can cause some issues later on. So a better approach is to just create a simple single list, which we can do by flattening the list. Okay, we can flatten the list by connecting a flatten component. So let's run the flatten tree command. Okay, so let me disconnect this. Let me connect the flatten node. And let me show you the list after flattening it. So now everything is in a single list, whereas earlier every curve was in a different sublist. Okay, so this will make our job a lot easier in the later steps. So let me delete that, and we will now fillet these offsetted curves. Again, don't forget to hide the previous nodes. Okay, now let's define a radius value, let's say 5 units. Let me connect it. And we can control how much we want to fillet it by. Let's say we want to fillet it by 1 millimeter. So we can write 1 and enter. Okay, so now the curves are filleted. In case you don't see the effect, it's most probably that you are still visualizing the previous steps. Now, once this is done, let me go back to perspective mode. And you can see now the curves are made. They are scaled inwards, and we have applied a rounded corner. All right, so the next step is to create the extrusions. We can either convert these curves into surface and extrude a poly surface, or we can extrude a poly surface and cap the holes. Either would work. So in this case, I will first convert these curves into a surface. So in order to do that, you will use a component called boundary surface. So what this component does is it takes a planar closed curve and gives you either an intact surface or trimmed surface. So let's connect these curves here. It's going to take a couple of seconds, and now you can see we have converted these curves into surfaces. Okay. Now the next step is to extrude it. So let's run the extrude command, surface, freeform, extrude. These are the surfaces that we need to extrude, and we need to extrude it in the y-axis. So let's go to vector, vector, and create a unit y vector. Okay, let's connect it. It is going to take a couple of seconds because now we are performing some multiple set of extrusions, and it can take a while. So let me extrude it by, let's say, 400 millimeters. Okay, you want, if you want, you can hide the previous nodes. All right, so there we go. These are extrusions that we need for the boolean operation. So for a moment, I will hide the extrusion. And now let's extrude this surface so that we can remove these extrusions from that extruded part. Now let's import that surface in Grasshopper. So I will just create a new surface container. You can go to params, geometry, surface, and right click, set one surface, and let's select the internal trimmed surface. Okay, this one. Now I will extrude it, extrude this surface in the same y-axis. You can also double click and look for the y vector. Okay, and I will extrude it by 50 millimeters. So let's create a number slider of 50 units. Okay, we can hide the previous nodes. So on one side, we have these extrusions. On the other side, we have the hexagonal extrusions. Now we will perform Boolean difference, which in Grasshopper is called solid difference. Okay, so let's go to intersection, shape, solid difference. So the solid difference component has two inputs. The first input, brep A, is from where we want to remove the material from. In this case, the block of extrusion. Whereas in input B, we have to define with what we want to remove the material, which in this case are the hexagonal extrusions. Now be careful, this operation can take a lot of time, and if your computer is not powerful, it might even crash. So the safest option is to just save the file first. So let's go ahead and save the file. Let's define a name, test, texture, hexagonal, and press enter. Now let me connect this thing here. It's going to take a couple of seconds, and you should be able to see the result. You need to hide everything except the last component. So let's select everything, middle mouse button, disable preview, so that you can see just the last output. So you can see this is pretty good. You can also notice that beneath the components in my Grasshopper interface, I can see how much time that component has taken. You can also double click on a component to change that time from percentage. This is shown because of a tool that you can enable by going to Display, Canvas Widget, Profiler. Right, so this has been converted into an extrusion. Now, this geometry doesn't exist in Rhino. If you want to convert this Grasshopper geometry into Rhino geometry, you have to bake the output. Okay, you can do that by selecting the node, middle mouse button, and clicking on this fried egg icon. Okay, this is going to bake the output. It's going to take a couple of seconds, and now you can see we have the exhaust vent baked in our Rhino environment. If we want to change anything, we can delete this iteration, go back in Grasshopper, change the parameters, wait a couple of seconds, and we can rebake the new version. Okay, so now this geometry is made in Rhino interface. We can integrate in our model. The next step is to extrude this skin surface, okay, of the exhaust. So I have to recreate a similar configuration where we import the surface, extrude it by some amount. Now, rather than recreating it, you can select these nodes, okay, Control C, Control V, and we have created a copy of the entire script, okay? And rather than importing the original surface, the one that we had here, we are going to import this one instead. So first, let me clear the values to delete anything that was inside of the previous container. Right click, just like before, set one surface, the outer surface. Okay. You can also enable the preview so that you can see what is the extrusion amount. So in this case, the previous one was extruded till 50, but this one I want extruded till 70. Okay. So that is the final output. I can also bake it. And now we have the overall geometry. Let me hide the other nodes. Let me close Grasshopper, save and close. And now I have already imported these geometries from Grasshopper for you. So if you want, you can unhide this layer, the bake layer, okay? Make it enabled and hide the previous one. So I've already imported these geometries for you from Grasshopper. I have also assigned a color so that it's easy for you to visualize it. Okay, now let's enable the assembly, and there you have it. Let me also create a mirror copy. I have already done that for you, but let me show you how you can do it. Let's select the mirror command, select the two geometries, press enter. Now, if you want to mirror it on the opposite side, you have to select any middle point here and use the shift key to lock it into 90 degrees. Okay, so there we go. So this is how you can create your own vent texture inside Rhino and Grasshopper. Let me extend the panel tab. And we can also right click and go to the rendered viewport. So this is the final output. You can also go to materials, create new materials, and assign to different parts. Feel free to share new variations of the texture with us. You can tag our social media, and we will also share this with our design community. I hope you liked this short tutorial. Feel free to reach out to us if you have any questions, and do share with other people if you found this useful. You can also check our live courses on our webpage related to Rhino, Grasshopper, as well as texture. Link is in the description. Thanks for watching this. Talk to you guys in the next one. Take care.